You may now begin your presentation.
Hi. Is it better to be rich or to be the superhero who's going to save our planet? 4 years ago, when I started my PhD, I realized that they can be both by recycling the electronic waste. The electronic waste, like your old cell phone or your old computer, are everywhere. Last year, the world has generated over 50 million tons of electronic waste, which is equivalent to 1,000 Titanics. Electronics in general are made of metals and plastics. The metals, and more specifically the precious metals like gold, exist with very high concentration in the printed circuit board, 300 times more than the ores. But we have a problem. Our metals are mixed with plastics, and these plastics are mixed with flame retardants, which is a chemical material used to reduce the flammability of electronic waste, and also many other products. The main problem that we have here is that in order to extract this metal, we need to separate the plastic from the metals. And that's why we have a big problem with plastic, as if we try to burn them, we're going to release toxic emissions. That's why Canada recycles only 10% of their electronics, and 90% of their electronic waste are landfilled or incinerated or traded illegally to other countries. And for the two methods that exist here, we have the mechanical way. The mechanical processes are very cheap in operation and cost, but they suffer from three major problems. The first one is that we can never achieve 100% separation for metal and plastic, and this is due to the overlap between the physical properties of the two materials. So we're always going to end with metals with plastics and plastic with metals, and this leads to a lot of precious metals that can reach 20%. And because of this, we lose also the plastic, which is not recovered or recycled, so it's always landfilled or incinerated. We have also a third problem, which is the dust that are generated during this process that can lead also to fire and explosions. The second solution that we have are the smelters. The smelters are use furnaces with very high temperature to melt the metals and burn the plastics. Smelters also suffer from many problems. The first one is the recovery of plastic that was not achieved because the plastics serve as a source of energy to melt the metals. The second problem is by burning the plastic, we are releasing toxic emissions. And the third problem is the recovery of metals from the pool of multi-metals that we have, which is a really extremely difficult process. And we lose over 10 to 15% of our precious metals. And also, it requires a lot of money as investment. And here comes Pyrocycle to propose a new green thermochemical process for recycling electronic waste that can recover 100% of it, including metals and plastic. How we do this? We do this by breaking down the plastics and decontaminating them and transforming them to value-added products like gas, oil, and carbon. And for the metal, they are liberated, and because we use a very low temperature, we are not melting them. We are keeping them in a solid state, and we extract them in a selective way after that. To see an example or to simplify this, we have 4 main steps. The first one, size reduction. The second one is a decomposition or breaking down. The third one is a decontamination. And the last one is extraction of our product that includes the base and precious metal like copper, gold, silver, platinum, palladium, and also our liquid product, which is oil, where we can extract phenols that can be sold as a chemical. We have also carbon that could be sold as a chemical product, and the gas that could be used or burned to produce electricity. Pyrocycle is not a collecting or a sorting center. Actually, we are coming after this center who provide us the waste material, and we process them and provide a primary material that could be used to generate or to fabricate or to construct or manufacture new electronic equipment. So we try in using this way to ensure that we have a closed cycle or a closed life cycle or closing the loop of electronics in general. Pyrocycle in general went through different stages, starting from a research project in the lab and the proof of concept that was done in Polytechnique Montreal in my lab. And then we moved to another stage, which is the validation and demonstration, and that was done also in the incubator of the university. And now we are working on building our pilot scale unit in order to meet the requirement or the high capacity of electronic waste that we have in Canada. PyroCycle also received a lot of investment and also grants from the government of Quebec that we have, the Ministry of Innovation, that help us during the early stage and also the current stage where we are building our pilot scale. We received also over 32 awards, including research, innovation, business, in the student level and also professional level. We also care about our impact on our environment, also socially and environmentally. Socially, PyroCycle is creating jobs in many fields, including maintenance, engineering, chemistry, business. We are also collaborating with different schools and also universities to provide workshops about sustainable electronics, and economically, because we are recycling or we are recovering precious resources that includes the precious metals and also rare earth elements that have a big value. And the most important, we are preventing a problem that's facing our environment in Canada, and we try by this to have a significant effect or significant way to avoid or fight climate change, and we hope at the end that we can make our planet green again. Thank you so much.
We will now begin the question and answer period. Judges, please raise your hand if you have a question.
Thank you, Mohamed. Well done. The one slide there was, with the truck and then the facility and the separation, like that looked fairly like a pretty heavy slide. So I guess my question is more on the financial side. What is driving your revenue? Is the end products, the gold? I know you have a forecast for gold in your presentation. Or is there an environmental sustainability piece to there? Like that was a very heavy slide. How are you going to pay for all that, and what's driving that?
What's driving me?
No, what's driving the business model? How are you going to be able to cover all those different touch points?
First, it's mainly environment, because if you are talking about just the printed circuit board who make money, it represents only 3% of the total of electronic waste. So we are caring more about the plastic, which is a big problem and represent 97% of our problem. So we are mainly focusing on the environment while creating a value or more money from the precious metals.
So have you identified the size of that market and what you can, environmental sustainability, I don't think is going to pay for everything. You're going to have to sell product, I would assume. So have you identified, obviously you know the amount of waste. Have you identified the cost to separate that and then create revenue from the products from that to pay for the business model you have?
Sure. Based on what we start as a research project, it started with a preliminary techno-economical evaluation or study to see something like a preliminary test of how we can make revenue or profit based on what we can spend. We did this in a small level and when we were doing the validation or the demonstration, and now it's a part of our business plan in order to get more grants that we are looking more now because we need to hire a team. Also, we need to buy new equipments and in order to meet the capacity that we are facing in Canada now.
Yeah, hey, over here. So you're downstream in the supply chain, so you get printed circuit boards that have already been processed and grinded up, or you do some of that processing? Okay.
As I said, we are not a collecting or sorting center. PyroCycle is coming after this center and after also the telecommunication companies. As the telecommunication companies also are having a big, forced by the government to find a way for the problem with electronics. So that's why we have also, we received a letter of intention from one of the biggest companies of telecommunication in Quebec as a supplier of electronics. So we are not just focusing on printed circuit board, it's electronics in general, and we are receiving the sorted material, including plastics or printed circuit board, and we process them in our facility, like grinding and the next steps.
Right, and then with your industrial scale plant, you're talking about 2 tons per day of material. That's quite a lot. Do you have concerns about the supply chain in terms of getting that material? I understand this market as well. People do buy it. There's a price to buy these printed circuit boards. They're not always free.
Okay, for the telecommunication companies, there is no problem because, as I said, the government is forcing these companies to find a solution. So they are providing us this material free, and we're going to charge them after this. In the beginning, it's for free. For the sorting and collection center, they are already having business with the smelters. But what we propose for them is part of our profit or revenues that we're going to make, which is higher than what the smelters pay for them. Because how the collection centers sell their electronic waste in batch for these smelters. They don't have a big value, they don't get a big value because of it. But for us, we are selling precious metal directly, and we can provide a good profit or good agreement with them. That's why we have already 4 agreements with 4 big collection centers in Quebec because of this.
Perfect, thank you.
Do you have any idea how much labor it'll cost? How much labor it'll cost you to extract your 0.25 gold a day?
How much? Sorry.
How much how much work? How many staff? How many people? What's it going to take to do it?
For the lab, so I'm going to go from the different stage. For the lab scale, I was working alone. For the second stage, where we did the validation and demonstration, I was working with 2 interns who joined me last year. And now we are working in a large scale, so we need to hire a team. We have no problem with intern, but we need to hire a full team, including someone for the operations, someone for engineering, and with addition also with interns who can help us during the operation. But for working with grams, it was just me. For working with kilogram till 50 kilogram, we were doing this, me with 2 interns last year. And to go more, we need for sure more employees or interns, but we need full-time employees. That's why we are looking for more grants or money to hire people as a full-time, because in order to meet the capacity for recycling.
Thank you. Very interesting.
Hi, Mohamed.
Hello.
Great presentation. I don't really get what you do. I get that you're trying to, eliminate e-waste. I can't picture your business. Is it a thing? Is it a lab? Is it, because you're not a smelter, you're not a place.
Okay, to simplify this, it's like a unit or a machine that so we first grind our waste using a grinder.
So you built a machine.
We have a product, yes, it's a machine, yes.
Okay, it's a machine that takes e-waste and breaks it down to basic components, and
Exactly.
then you sell those components?
For the beginning, we are recyclers. What we are doing now is our objective is to build an industrial scale. So this is what we are doing now in Montreal. After this, we're going to be a seller or provider of the system we are using for recycling. So we're going to be licensing our technology after this.
So your business model, if I understand, is you're building your minimum viable product, which is this machine, and then you license out this machine around the world.
For other countries, yes. But in Montreal, we already are established there, and we want to be the recycler in Canada. This is what we target in Canada. But for the other countries, like the African countries, for example, we have many contacts there.
Your one machine processes all the material in Canada?
Yes, for Canada, yes, we're going to be the recycler. But for other countries, we're going to supply or provide the system or the machines that we're going to use for recycling.
Okay.
How much does it cost? By the way, great presentation. How much does it cost to build a machine?
Okay, for which scale? For
Full scale. So now
for the full scale, we are looking for between 2.5 million to 3 million.
Just to build the machine? Okay. And then what's the operating costs?
The operating cost is very low. It's not very huge. It includes just the materials that we can use to mix with, because we can say the magic happened in our process using the ingredients that we use. So we have some ingredients that we buy, but we also recycle them.
Right.
But part of our money is also going to be spent on buying some ingredient for our process.
And will there be IP in the machine, or is it know-how, or?
Okay, the patent that we have is already shared with the university, so it's patented by the university. 50% belong to us now, and we already have an agreement with the school to transfer for us 100% of the IP after reaching some milestones. And then we can also license this to other users or other countries who need these machines to recycle their waste.
Okay, thank you.
Over here. Could you, you've talked about this machine. How many machines would you need to serve the market in Canada? And what type of people do you need to have working with the machine? Are they PhDs or are they manual laborers? What kind of people do you need as you scale this up?
Okay, so what we are targeting now in our capacity, we want to reach 2 ton to 2 ton to 2 ton and a half in a year by machine, but we should be able to produce. The idea is not to build the big machines, but to have machines that is acceptable that we can use to build parallel machines that operate in the same time. So the idea is 2 ton and a half is not very efficient or sufficient. As in Quebec, last year we produced over 20,000 tons of electronics waste. So this was collected just in Quebec. So 2 ton is not a big volume, but the idea is we want to have parallel machine operating in the same time so we can meet the requirement. And it doesn't need like someone with PhD to operate this machine. It's automatic, but the other process, if we need like extraction or other process like this, it requires engineers or chemical engineers or people with experience in chemistry.
Thank you so much. So given that it's quite an expensive build out, okay, I have a 2-part question. One, does the machine require like a constant input of materials so as to optimize on the back end what it results in?
You mean batch processing or?
Yeah, so I've been exposed to a different style of machine that produces hydrogen and energy on the backside, and so it requires like a constant feed in order to increase productivity of the output.
So what we have now, it's a batch processing. So the 2 ton and a half is based on a batch processing. But if we need to go for larger capacity, a continuous process is going to be recommended for sure. And we have already a design for this, but we are not in this stage now. We are working more in a batch processing to prove the concept in a larger scale.
Okay, so that's my next question. So it is in a larger scale, because then my mind goes to say, okay, in the developing countries and or ecosystems where we don't have that kind of infrastructure, in order to put a machine like this, it's not any time in your near future to have a smaller ability, smaller scale.
Sure, this is one of the ideas that is already we thought about this, because most importantly in Africa or Ghana is a big problem there. It's considered as the biggest landfill of the world of electronics. So we are not going to provide big machines that require millions to buy it. We're going to provide small module or small machines that could be used even in the village or cities, so we can solve the problem in a certain way.
Great presentation. Can you speak a little bit more about the government regulations in other countries?
Sorry?
Can you speak a little bit more about the government regulations of how electronics are recycled in other countries?
In other countries, okay. Other countries, you mean, for example, China, what they were doing is always receiving the waste of the world and burning them there using smelters or others. But they had a big problem recently, and last year or 2018, they decided to not receive more waste from North America. So that's why we have to deal with it here. But for China, they're already using smelters. African countries, they don't have any technologies there. They are burning this in the street, children, women, and they are burning this just to recover the precious metal. And for other countries, they can use mechanical process. It's really cheap. This is the best thing that you can do. In Egypt, where I come from, we are just collecting and sending this to European country, mainly in Germany, for smelters too. So we can have just burning it in the street, mechanical machines, smelters. This is what the world doing now with electronic waste. There is no better way to do it till now in the world without having a harmful effect on the environment or losing a value during the extraction of precious metals.
I'm still a little bit confused. So just to dumb it down for me, I take my computer and I stick it in one end, and out comes gold and other carbon and...
Okay.
I'm having trouble picturing
Okay.
what this...
My old phone is here. Yeah. I'm gonna crash it. I'm gonna grind it. I'm gonna put it in a machine. I'm gonna add my secret ingredient to this process. The plastic is gonna be melting or break.
Your time has expired. Please help me in thanking Mohamed Khalil.